we're going to integrate the integral of tangent x to different positive integer powers. So our first example, I want to do the antiderivative of tangent x to the fourth power. In doing these powers of tangent, we have to get the derivative of tangent somewhere in there. So we need a secant squared. So in this one, we're going to have tangent squared x, and then we're going to break out a tangent squared x dx. And that tangent squared will get replaced with secant squared minus 1. So this becomes secant squared x minus 1. We're going to distribute the tangent squared through, and I'm going to write that as two integrals. So it's tangent squared x times secant squared x dx minus the integral of tangent squared x dx. This is a nice u substitution, u being tangent x, then du would be secant squared x dx. So this integral just is u squared du. But this tangent squared, I don't know that antiderivative, but I do know I can replace it with secant squared minus 1. Working this, I have that this tangent squared secant squared was really the antiderivative of u squared, so I get u cubed over 3, and that just gives me tangent cubed x over 3. And now we're going to do this, so I'm going to distribute the minus through, and I'm going to get two antiderivatives. So it's minus the antiderivative of secant squared dx, and then we had minus a minus, so it's plus the integral of 1 dx. And that gives us, working this, we get minus the antiderivative of secant squared is tangent x, plus the antiderivative of 1 is x, plus a constant. So that becomes the result for the antiderivative of tangent to the fourth power. Now we're going to do the antiderivative of tangent x to the fifth power. So we pull out a tangent squared, which leaves us with a tangent cubed. Then we have the tangent squared dx. We are going to replace the tangent squared with secant squared minus 1. Distributing this through, I'm going to get two integrals. So this will be the integral of tangent cubed x secant squared x dx minus the integral of tangent cubed x dx. The minute we see we've got a secant squared, this is a perfect setup for u being tangent x. The derivative of u then is secant squared x dx, and this integral becomes the integral of u cubed du. This other integral, we will have tangent x, and then we'll have a tangent squared x dx. Whenever we see the tangent squared, that's a perfect setup to replace it with secant squared minus 1. Working this from left to right, we have this first integral, the antiderivative of u cubed is u to the fourth over 4. And that gives us tangent x to the fourth power over 4. And now this second one, we're going to distribute the tangent through. So it's minus the antiderivative of tangent x secant squared x dx, and minus a minus is plus the antiderivative of tangent x dx. Working tangent x secant squared, this is a u substitution again, and we get the integral of u du, and that's going to give us u squared over 2. So that gives us minus u squared over 2 tangent squared x over 2. And we memorize this antiderivative is log of secant x plus a constant. And so sure enough, that's the answer for the tangent x to the odd power, to the fifth power.